objective of this session is to discuss math first diagnostic. Okay, math 1. And so you all gave it this last week and you had a chance to give it again this week. Okay, but only a couple of you tried. But anyways, let's go ahead and solve this 10 questions right now. Anyone here getting above 10 here? Okay, so most of you got negative marks. That's how difficult this paper is. Okay, but some of you also kind of managed to score 10 plus here. This is math diagnostic. Okay, first question. Let AX equals B a system of M linear equations in n unknowns with M less than n. Okay, we have more number of unknowns. B is not 0. Then the system has n minus m solutions. Either 0 or infinitely many solutions. Exactly one solutions, n solutions. So by now you should at least acknowledge that this is never the case. This is never the case. It's between B and C. Linear system either has 0 solution, it's inconsistent, or it's consistent. In that case, it's either going to have a solution or it's going to have infinitely many solutions. So which one do you think is the answer here? We have the chat active. B, and a quick explanation for that. See, this can happen only if row of A, okay, equals row of A given B, okay, equals n. But this is not a possibility because m is less than n. Row of A has to be, okay, less than or equal to m. Unknowns are more, so unique solution not possible. That's one way to think about it. More number of unknowns. Okay. More unknowns than equations. Okay. Now, what is the 0 or infinitely many solutions? Notice we have 2 more cases. We have more space here. Row of A. Okay. If it equals row of A given B, then say this is less than or equal to m. Okay, that is row of A equals row of A given B less than or equal to m. In this case, we know there are infinite solutions. And then we have another case where row of A is actually less than row of A given B, which is less than or equal to m. In this case, we have no solution, 0 solution. Okay, the answer here is B. This is a very, very basic question. There is usually one question based on this rank and number of solutions, systems of linear equations. The theory is the same. It's always this 3 conditions, okay? Even if you don't understand them, if you can recall them, you can answer this question. Okay, let's go to the second question. Limit x tends to pi by 2, x square sine square 2x by x minus pi by 2 whole square. How do we solve this? One way would be to use L'Hopital's rule. Okay, let's try that for everyone's sake here. So I'm going to try method 1, L'Hopital's. Okay, so this is, notice this goes to 0. This also, this denominator goes to 0, so we somehow want to get rid of it. Okay, so we have like limit x tends to pi by 2. Okay, then we have 2 sine 2x. Okay, and derivative of sine 2x, that will be what is derivative of sine 2x, that is cos 2x, into derivative of this, that is into 2. Yeah. Okay, so we know how to take derivative of compositions, so which is what I have done here. This is derivative of sine square 2x. Okay, and then we have derivative of 2x, that is showing up here. Then if we differentiate this, we have 2 into x minus pi by 2. The derivative of that is 1. Is this fine? No, this is still indeterminate. Let's do one more derivative of this. So notice, realize this is going to be limit x tends to pi by 2. Okay, we'll make some aesthetic changes. This is the 2, this 2 and will get cancelled. Okay, what we have here is 4 sine 2x by x minus pi by 2. This, sine 2x is 2 sine x cos x. I'm kind of using that relation. This is sine 4x. Okay, if we take one more derivative, we'll get rid of that singularity. So let's do that. This is limit x tends to pi by 2. We have 4 cos 4x into 4 by 1. Okay, what is, this is, I think, this is in a determinate form. What is this limit? Cos this equals 4 cos 4 into pi by 2. Okay, so 4 cos 2 pi. So cos pi, cos 2 pi is 1. Okay, notice we have 0 pi Then we have 2 pi period. So cos is 1 there. So this is 4. So here you need to know how to do this composition of function. How to take derivative of f of g. How do you take derivative of this? This, if you know, you can kind of easily proceed. Let's also look at a method 2 for this problem. Okay. Notice another way to do this would be directly use the expression over here. Okay. So we know this is square of sine 2x. Sine 2x. Sine 2x is 2 sin x cos x. Right. So what we have here is limit x tends to pi by 2. Okay. 4 sine square x cos square x by x minus pi by 2. Okay, x tends to pi by 2. This is a nice term. This is 1. Sine pi by 2 is 1. That's a nice term. But this is 0. This is 0. Pi by 2 minus pi by 2. So question is, what is cos x by x minus pi by 2? We all know this limit. Okay. X tends to 0. Sin x by x we know is 1. There's also one more limit. X tends to 0 or x tends to pi by 2. Okay. Cos x by x minus pi by 2. Quickly again, if you don't remember this, notice this is x tends to pi by 2 L'Hopital's rule. That is minus sin x by 1. Again, x tending to pi by 2, that is minus 1. So this term really is actually has a limit of minus 1. So this is actually, you could directly write it. This is 4 into 1 square into minus 1 square. Minus 1 square. That again is 4. Okay. So this I suppose is D, right? So this is method 2. Again, this is basic. This is here you need to know a limit. Even if you don't know it, you could kind of guess it. This is a 0 term. This is a 0 term. Quickly try to use L'Hopital's rule to find it. Okay. Here you need to know how to do derivative of composition. Okay. The coefficient of 1 by z minus 1 in the Laurent expansion of f of z about z equals 1s. Let me ask a slightly different question. Okay, let's get some clarity. Notice this is of the form 1 by 1 minus z, okay, into 1 plus z. So bigger thing work. And this is fine, right? So notice at least there are like a pole at z equals 1, z equals -1. So what they leave something called residues. All they are asking is what is the residue of residue at z equals 1. So this step now is almost like a partial fraction expansion. We have talked this again and again. Okay, how do you find coefficients in partial fraction expansion? Okay, partial fractions. Then we have Taylor series. How do you get the Taylor series? We discussed in class. Okay, and then we have Lorentz series in complex numbers. And then we also have residue of something in complex series. All four kind of make use of the same trick. Okay, we have discussed this many times. In live class, we did this. During admission mock, we discussed partial fractions. Taylor series we discussed in live class. Lorentz series is kind of well explained in the recorded videos. Both of this kind of connected together. So how do you find this coefficient? That is very simple. Answer is f of z. First, remove that singularity. Okay, so multiply that by z minus 1. You remove the singularity. Now we evaluate it. See, interestingly, these are first order poles. So our life is much easier. You are expected to know this for second order, if not for nth order. Right? This pole is first order. Then evaluate it at z equals that point. So why we do this is, as I said, well explained. Okay, notice this is going to be -1 by z plus 1 and value at z equals 1. Okay, that is -1 by 1 plus 1, that is -1 by 2. Okay, see, notice what we did here. The coefficient is essentially the residue. Okay, it's a very fundamental step, and yeah, it shows up at many places. And be careful, they are asking for coefficient of z minus 1. So you always multiply it by z minus 1 to get rid of it. Okay, so this sign will persist. What you have here is 1 minus z. So when you multiply by z minus 1 to get z minus 1's coefficient, you have -1 remaining. This is a chat child. Okay. Let's look at this problem. Number of n by n matrices that are simultaneously Hermitian, unitary, diagonal. Someone seems to have a question. So raise it. Okay, in this question, what if they ask for coefficient of 1 minus, 1 by z minus 1 whole square in this question? What do you think is the answer? If you expand this function using Lorentz series, what will be the highest power of negative power of z minus 1?
right? So this is a first order pole at z minus 1, z equals 1. So only, first order pole will remain in the Lorentz series. Second order, third order, and all that won't be there. Had this pole been nth order, there will be like 1 by term still 1 by, yeah, all of them, rest of them are all 0. Yeah, exactly. In fact, that's also a nice question. What will be the coefficient of 1 by z minus 1 square in the Lorentz series expansion of this? It's a first order pole, so answer is 0. We directly say that. Okay, let's again, that's a nice point. Okay, so modifications. Modifications here. Okay, first is residue at, same question, residue at z equals 1. Of course, the moment they can ask you for residue, they can club this with one of the versions of residue theorem and ask you find an integral or so and so. Second is the same question. What is the coef or residue, as Priyansha asked, coef or residue of 1 by z minus 1 whole square? The answer here is 0. Okay. Answer is 0. Here answer is same. Answer is same. Okay. Third complication. They can make this slightly different. What is your f of z? They can make it. F of z is 1 by 1 minus z whole square into 1 plus z. So there is a second order pole. Notice both these terms will have coefficients 1 by 1 minus z, or 1 by, no, there will be a by z minus 1 term. And then there will be, let's call it a1. There will be an a2 by z minus 1 whole square term. Okay, other terms will be 0. a3 by z minus 1 cube will be 0. Okay, and rest of them will be powers of z minus 1, positive powers. Power 0, power 1, and all that. Like that. You don't have to worry about it. Again, in the class, recorded class video, how do you find this? How do you find any coefficient is kind of explained. Okay, now let's get to the next question. Okay, that is fourth question. Number of n by n matrices that are simultaneously Hermitian, unitary, diagonal is dash. Let's get some answer. Only detail here is I don't think we mentioned what is a unitary matrix in class. Hermitian we kind of study, diagonal we kind of know. Okay, Hermitian, it's like symmetric matrices for complex matrices. So A equals A transpose for symmetric matrices. Okay, complex matrix equals its conjugate transpose, not just normal transpose, but also put conjugates for each element. That is the star. Okay, so this we already discussed. And here we have unitary matrix identified. Okay, this is like again the orthogonal version of complex matrices. So U star is I. Okay, and your U star is conjugate transpose. Given a complex number, it's conjugate. So write the conjugates of all elements and then do transpose. Okay, now that I said what is what diagonal, I suppose all of you know. How do we answer this? Can we complete the answer at this? Okay, let me ask a simpler question. How many such diagonal matrices are there? Forget Hermitian unitary. Simultaneously Hermitian unitary, forget that. Simpler question. How many such diagonal matrices, how many n by n diagonal matrices are there? Notice we have this element as non-zero. These are all 0, 0, 0. Okay. This element is not diagonal is non-zero. These are all 0, 0, 0. Okay. This element is there non-zero. It goes on like this. Again, we have 0, 0. It goes on. All of them are 0. Okay. So only this diagonal elements are non-zero. All of them are kind of 0. That's a definition of a diagonal matrix. If you look at the r through rth column, the rth diagonal element, it will be of the form AR, because we are referring to complex matrices, plus, okay, R, that is A is some, AR is some scalar, J times BR. R is just an index, A plus some complex number, okay? There is a complex number here, there is a complex number here, there is a complex number here. So to distinguish them, I put an index here. Okay, how many such diagonal matrices are there? Even forget AR plus JBR, forget JBR. How many diagonal is a scalar? How many such matrices are there? Think about it. Okay, how many diagonal matrices are there? Any element can be a real number for matrices, right? There are infinite such matrices. Even if you assume all of them are same, okay, AR can take any real value. So there are infinite such matrices. Can minus infinity to plus infinity, any value can be filled here. 0, 0 0.1, 0 0.11, 0 0.0011, right? All of them. Okay, so diagonal is the strongest condition there, so I first put it. I know all the other elements are 0. If you look at the rth diagonal element, it's going to be AR plus J times BR, because we are talking about complex numbers. Okay, it's a Hermitian matrix. 1, 2, and the third condition is over here. We put it as a third condition. What does condition 1 imply? It also has some space. This implies even for the rth row notice, specifically for the rth element, AR plus JBR, okay, should equal every diagonal element is same. If you look at the rth element, complex conjugate is minus JBR. And what should this imply? And many seem to be keep on leaving the chat. Is there a signal issue, audio issue? What kind of issue is there? Yeah, so thanks, Priyanshu. So Priyanshu is the one who is kind of answering all the questions. Okay. Notice for this to be the case, okay, this is actually two equations. Real part has to be same, imaginary part has to be same. AR equals AR, fine, yeah. BR equals minus BR. Only way that is possible is BR equals 0. First thing is this is actually a set of two equations. You have to, real numbers has to be same, imaginary part has to be same. Okay, so this is BR equals 0. So the number we are looking at is actually very, very simple. It's just of the form AR. It's a real number. Then this condition, U star is I. That is AR, U star is again AR. There is no, this is just real number. Its conjugate is still just AR. That equals 1. Here AR, this implies AR equals plus or minus 1. Square root of that. So at the rth location, it can be plus or minus 1. Now at least can you answer? Can you all answer? What should be, what is the option here? Rth location is plus or minus 1. There are n locations, 1, 2, 3, dot, 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 or dot, 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 n. Rth location can be plus or minus 1. That is, any location is plus or minus 1. What is the set of all possibilities? There are two possibilities in the first term. There are two possibilities in the second term. All of them get multiplied. Almost we have like R spots. Each spot can take plus or minus 1. Two possibilities here, two possibilities here, two possibilities. So, 1, 1, 1, 1, 1 is a possibility. 1, 1, 1, 1, 1. Last element is a minus 1 is a possibility. First element is a minus 1 is a possibility. So like that. That we know, right? Each location has two possibilities. There are n locations. So the answer is 2 power n. Okay. So notice, okay, this is a slightly advanced version of what they asked in GATE, but once you understand the question, it's actually very, very simple. Let's do this one bit. Yeah, the value of the contour integral. There is, sure, Sean, there is one question from this. Residue theorem, there is either they are going to ask you the residue or they are going to ask you the integral. Certainly one question is there from that. All you have to do is know how to find the residue. First, let's understand this function slightly better. This is e power z plus e power minus z by 2. So numerator is okay, e power z exponentials. Denominator is okay, there are some poles there. Cos h z by, notice to get the poles first you have to keep coefficients of z as 1. Okay, so I'm pulling out a 4. This is z square plus 1 by 4. So there is a dz. And at appropriate locations. This we know how to factorize. Okay. Again, for clarity, let me write it over here. Closed contour. C is the z mod z equals 1. That's a circle, unit circle. Okay. Cos h of z by 4 into z plus j by 2. We know the roots of this equation is plus or minus j by 2. Okay. Into z minus j by 2. Now we know that. So this is, of course, at this stage, this is residue theorem. If a pole is inside the contour, we have the residue for that shows up. We have the unit circle, complex plane. Okay, unit radius is 1. Okay, we have plus 1, we have minus 1, we have plus j, and we have minus j. The 4 corners. The 2 poles are j by 2 minus j by 2. Both are inside the circle, inside the contour. So residues of both will show up in the answer. Sum of the residues. Okay. Sum of residues. Okay, what is that? That is cos h of z. Remove the first residue. Okay, by multiplying it by z plus j by 2. So you're left with z minus j by 2. Evaluate it at minus z equals minus j by 2. Again, for clarity, z equals minus j by 2. And we know that there is a 2 pi j factor also here. This is the first residue at z equals minus j by 2. Then there is one more residue, because that's also inside the circle. Cos hz by, remove that pole corresponding to z equals j by 2. What you are left with is z plus j by 2 evaluated at z equals j by 2. Notice there is a factor of 4. Let's pull it out. Now, if you evaluate this, you will get the answer. Two pi j by 4. This is cos h minus j by 2 And if you plug this here, z is minus j by 2, you have minus j plus cos h of j by 2 by j by 2 plus j by 2, that is plus j. Okay, now can you at least complete the answer here? You can pull the j also kind of outside. Okay, so you have 2 pi j by 4j, pull the j outside. So this term is cos h of j by 2, okay, minus cos h of minus j by 2. That's what we have. At least can we answer at this stage? We have to know what is, of course, is cos h, hyperbolic cosine function. Cos h of z, right? Cos is this e power e power I theta, e power j theta plus power minus j theta by 2, right? If you put a h there, remove the j there. So e power z plus e power minus z by 2. So this is actually symmetric in z, or this is an even function. So this value is going to be same as this value. It will get cancelled and you get a 0. Cos x is minus cos x. It also holds good with cos hx or hz. That's it. So there is certainly sum of residues. There is certainly one question, either residue directly or sum of residue. Direct residue question is over here, right? That find the coefficient of 1 by z minus 1. Sum of residues question is over here, of course, because it's complex variables. They can always mix it with a complex function like hyperbolic cosine. Let's proceed further. Okay, f of x plus jy equals u. It's a complex function in x and y. It's an analytical function defined on the complex plane satisfying 2u square plus 3v square equals 1. Then, okay, can we quickly answer this? How do we answer this? So there are two conditions given. One is it's an analytical function. Second is it satisfies some relation between u and v. This function and this function. That is this condition. What is a quick way to solve this? It might look actually very hard. And if you want to proper answer, find the answer. The options are not given. If you want to find the answer, it's also very, very long. But we know this is an MCQ. We always, when we are kind of lost reading a question, we will always look at this. Can we verify, right? Can we find our lost key? Lost key. Can we verify? Right? So that's our method one. Any answers here? Is there any way we can eliminate couple of options here? How do you eliminate first one? Okay, this is in terms of equation. This is not in terms of equation. So let me write that equation. Ux equals Vy. Uy, where this denotes partials, I'm using the shortcut notation, minus Vx. Both positive summation of any constant cannot land on 1, because positive summation of any constant cannot land on 1. Why not? Us hey, I can just give you a counter example to your statement. This is let's say u is v is 0. Okay, u is 1 by root 2. You get 1. Yeah, you and v are functions. Actually, this is b is not possible because it cannot satisfy constraint 1. Violates 1. That is your f is kx plus jz plus, in fact, j times ky, right? Notice your ux is k, right? This is your u, this is your v. Your vy is jk, violates 1. This cannot be the case. Regarding 2, notice this is almost a circle, or in this case, it's actually an ellipse. You know, you can get this, any function of this form, cos square theta plus sine square theta is 1. So if we choose u as cos with a proper scaling, v as sine with a proper scaling, that is this 2 cancels, this 3 cancels, you'll get 1. Okay, that is any function cos of any function, okay, f of x comma y. All I need is to cancel that 2, so I'll do 1 over root 2. I'll choose this as my u. Okay, and then notice if we choose 1 by root 3 sine of f of the same function, sine of theta. But theta is any function. It can be x plus y, it can be x minus y, anything. Notice it automatically satisfies 2. So condition 2 suggests me to try a form like this. But the moment I try a form like that, it will automatically violate 1. You could check that, okay? Okay, notice ux is cos, minus sine f of x, f dash of something. Vy is, there is a 1 over root 3 factor, 1 over root 2 factor. They won't really get cancelled. Okay, again violates 1. Just take partials, you will see that. And then, so in fact, this solution cannot be possible. This solution cannot be possible. what we are left with is this constant. It's easy to make it satisfy this condition. Constant satisfies this. All constants satisfy one. Derivative is 0, ux is 0, vy is 0, uy is 0, my vx is 0, 0 equals 0, 0 equals 0. Okay. Constants are nice functions. In other words, they are analytic. Analytical, non-analytic functions has all the singularities and all that. Constants are nice functions. They are analytic. Constants satisfy one trivially. 0 equals 0. And you could always find a constant that such that this is 1. Okay, this is the elimination way. Okay, the point is, okay, there is going to be one question on this. But even this question can be answered easily. But if it is something like a NAT question where they find the value of f at a specific location x comma y and all that, it kind of gets really complicated. What you have to do in that case, let me explain that. Notice again, we have 2, we have 1. Okay, 1 says ux is vy, and then uy is minus vx. Also kind of very easy to remember, right? So now 2 says 4u ux, that is I'm taking differential partials with respect to x, 6v vx equals 0. If I take partials with respect to y, 4u uy plus 6v vy equals 0. Now you can use these two equations, okay, eliminate vx and vy. Okay, solve for ux and uy. Notice it's a simple, almost a linear equation if you treat all this as constants, coefficients, right? You will get ux equals uy equals 0. Then eliminate, do the other way around. You also want to find what vx and vy are, right? So eliminate ux and uy. Okay, solve for vx and vy. Again, you will get vx equals vy equals 0. All of them are 0, so it has to be a constant. So there is a using one. Somewhat of actually tricky step. Okay, now these two, solving these 4 equations is actually very tricky, nice exercise in understanding partial derivatives and all that. Okay, if we solve for them, of course, this is going to be 0, that's going to be 0. Okay, that's our method 2 for this problem. Yeah, this is the only unfair question in this whole paper, okay? Because the theory concerning that is not mentioned in class, live class notes, or in recorded videos. I would say this is the hardest question in the paper. But actually, if you know the theory, this is also one of the easiest questions in the paper. Did anyone figure out how to solve this? I kind of briefly mentioned about the kinds of solution for function form for wave equations. And also in transport equation, notice one of the gate BM PYQs, they put a transport equation and asked what the solution is after some time. They gave initial conditions. Anyone? Okay, what kind of a solution do we expect at least for wave equation? This you should be able to answer, right? What kind of a form? Forget exact versions, but what kind of a form? Sum of forward and backward linear equations, or forward delay, backward delay, advanced function, delayed function, sum of that. Right? Wave, it's going to travel forward and backward. The wave, whatever solution, initial condition you have. Notice, let's also understand this is the PDE. Okay. Then we have at any x, okay, at time 0. These are actually initial conditions. Initial conditions. So notice our u is going to be a function of x and t. At time equals 0, at any x, it has this function, linear function, that is a slightly shifted version of x. Dou u by dou t, okay, is partial of u with respect to t at 0 is 0. Okay. Let's call this function u naught of x. It's not a function of t. Let's call this function g of x. Okay. There is something called d Lambert's solution for the wave equation. Okay. PDE, specifically this is wave equation. For this initial condition, wave equation has a simple solution or a closed form solution. Okay. U of x comma t is going to be an average of forward and backward traveling wave. U naught of x plus ct plus u naught of x minus ct. Okay. Plus there is one more term here. Half of x minus ct to x plus ct g of x dx. Okay. D'Alembert's solution for wave equation. Okay, having said that, they made our life easier by giving g of x to be 0. They made our life easy by making one of the terms 0. This equals 0. Okay, solution is this. This function delayed and advanced by ct. And what is c? That of course we expect all of you to know. We have to. That you expect all of you to know. Okay, this is c square. Be very careful about the partials. Coefficient of second partial of with respect to x. That coefficient is c square. C equals 3. Sir, is it in plus or minus 3? Yeah, we have a plus c and minus c in the solution, so it doesn't matter. And wave, this is wave speed. So you always look at the positive speed, and of course it goes both the ways. Okay, can you try to answer the question right now? That is, after giving the solutions of this form of that integral is also kind of zero. Can we answer plug in? You know what is u naught of x? Can you plug in? You know what is c? You know what is x? You know what is t? Can we find the answer right now? Notice u of. Do we have more space here? Yeah. Notice this is half of. This is x plus 5. So x plus ct plus 5 plus. So this is u naught of x plus ct. Instead of x, I put x plus ct. Then instead of x, I put x minus ct plus 5. So interestingly, time doesn't matter at all. Time will get cancelled. So u of x comma t is actually just a function of u of x here. Okay, is this time doesn't matter. So u of 2 comma 2 is t doesn't matter. Only this x matters. Half of 2 plus 5 plus 2 plus 5. That is 14 by 2. That is 7. And you are expected to remember this. One of the reasons to give it in the diagnostic is so that at least now recognize this relation. PDEs, they always target some special solution, some special property of heat wave equation, etc. This already happened in GATE BM 2021. Okay, for the transport equation, they kind of expected you to know the solution. So I wouldn't be surprised if they actually want you to know D'Alembert solution. This is only actually a hard question in the whole paper. Okay. Let's go to question number 8. How do we do this? See, this is a question that this is just pattern template matching, man. You have a stencil, you have to write your name, right? You can write a name, right? There is a, stencil is a simple formula. If you use it, you can get it. What is the result we are going to use here? As soon as you see something like this dx, something like this dy, first thought is, can we convert it into, this is a closed contour, can we make it an area integral? The reason being, area integral, you take one derivative, can term somehow get cancelled. If it's linear, fine, you get a constant. If you take partials and kind of take derivative, kind of do subtract them, can they get cancelled? So first, my thought is, can I convert this integral? And there are only 3-4 theorems in the whole syllabus, integral theorems. One of the templates, one of the theorems you use, you get the answer instantly. What is the theorem that we should use here? Stokes or Green's version of that, right? special case of that. Stokes will be that full 3D theorem. Green's is this that 2D version of that. Also very easy to remember. L, M. First comes L, next comes M. First comes X, next comes Y. L dx, M dy. Integral, no derivatives inside. This is a contour integral. Integral along the contour, the closed path. The contour actually is a circle. From the point 0, 0, we are looking at x and y that are at equidistance. X square plus y square is the distance from the origin that is constant. So this radius of a circle 2. Okay. So this is that contour, and notice this is in anti-clockwise. First thought is, can we make it an area integral? The same contour. The order changes here. M partial derivative with respect to x minus L partial derivative with respect to y. Dx dy. Notice area integral of derivative inside that domain is integral at the boundary points, integral of the function without derivative. So we have L equals x y square plus 2x. Okay, so Ly, if we take partially of this is going to be, this term will disappear. X is a constant, only y kind of varies. Derivative of this we know it's 2y into x, 2xy. M, notice, equals x square y plus 4x. Okay, so M partial with respect to x, this term will give a 4, this term will give again 2xy. So mxy minus, m with respect to x minus L with respect to y, 2xy will cancel. So the answer is 4 dx dy in the contour, this area. 4 is a constant, you can pick it out. It's 4 times that area. Dx dy is the area of that region. That is 4 into pi r square. R square notices r is 2, r square is 4. Again, for clarity, let me make this 4 pi r square. That is 4 into pi into 4. That is 16 pi. Had it been clockwise, it will be minus 16 pi. Because the signs are determined based on whether it's clockwise or anti-clockwise. Formula we wrote is correct for anti-clockwise. Okay. So probability question, these two are simple. Okay. How do you solve this? 2 students take a test consisting of 5 true or false questions. To pass the test, students have to answer at least 3 questions correctly. Both of them know the answer to 2 questions. Guess the answer to the remaining 3. Probability that only one student passes the test is equal to. Did anyone solve this? I think a couple of you solved this. What is the strategy here? So notice this is pass fail or fail pass. Pass fail or fail pass. Two students. Let's take one student. What is probability of pass? Can we answer that? There are three questions. They pass if they answer at least one question, two question, or three questions. Slightly, there are three cases. Let's say you look at probability of fail. Just one student. Any student, any one student. What is probability of fail for one student? There are three questions. They have to get all three questions incorrect. All three questions, 3 out of 3 questions incorrect. So 1 by 2 power 0 into 1 by 2 power 3, binomial theorem. 3 out of 3 incorrect, 3 failures. That is 1 by 8. Probability of pass is 1 minus probability of fail. That is 7 by 8. This is the 3 cases. 3C2 1 by 2 power 3, 3C1 1 by 3 power 3, 3C0 1 by 3 power 3, 1 by 2 power 3. Okay, so we have sufficient info to that this is for this pass probability is 1 by 8, for this fail probability is 1 by 8, or for this fail again it's 1 by 8, or this pass this is going to be 7 by 8. Can we at least answer right now? Okay, at least I have almost given the answer, right? Can you complete right now? Yeah, 2 times probability of pass. Yeah, either that or notice this is going to be 7 by 8 into 1 by 8 into 2, or essentially 1 plus this, or so 1 by 8 into 7 by 8. That I suppose is 7 by 60 14 by 64, that is 7 by 32. Okay. Fine. And the last, see, notice, actually, once you explain the solution, the problem always is once you explain the solution, it's very, very straightforward. But to actually realize, okay, this is what they are asking. First, find probability of one student pass, one student fail. That use binomial theorem there, and then either do this case or that case. So 2 times that. That is not, that only comes with practice, and that has to come in within the 3-hour window you're on the exam. Within the 3-hour window without affecting a lot of time for other questions. Okay. So when I ask you to retake, these are all, practice opportunities for you. But I think most of you have at least given the first time, so I'm not going to bother whether you have given it a second time or not. Who was this? Okay. And the last question here, I gave it thinking that at least it needs one easy question in the paper. So that's why I gave that. Because there again, notice there is high chance of a question from system of linear equations. Okay. Limits, integrals, limits or integrals, we don't know what. Fine. Residue or residue theorem, there is certainly one question. Okay. Then if you look at, the residue theorem, residue or residue theorem, there is one question. Analytical function, there is going to be one question. Okay. PDE, they can really play around with you. If they want to complicate it, they can really complicate it. So that's going to be hard. Green's theorem, Stokes theorem, divergence theorem to find one of the tricky integrals by converting it into a either domain to boundary or boundary to domain conversion. There is going to be one question. It will look very, very complicated in the boundary. It looks very simple in the domain. Just area of the domain. Right. Again, the reason to tell you, okay, what they are essentially doing is, notice there is derivative integral of that inside a domain. This is function at the boundary. Both are integrals, right? So that is to aid, simple tool to start thinking of that conversion quickly. And there are only like 4 theorems. Then okay, probability theorems, this one question comes with practice. Though the solution one is that's it, 7 by 8 into 1 by 8 plus 1 by 8 into 7 by 8. But for that to come in the exam, it takes time. Okay, it takes practice. And Newton-Raphson, again, numerical methods, one of the easiest and most again expected question. Gate BM 2020 it showed up, and then I think 2020 it showed up 3 years. Newton-Raphson, okay, again theory. I also added a 5-10 minute video in the playlist. You could go watch it. Near numerical methods. Okay, you're trying to solve f of x equals 0. Okay, we talk about there is a quick, simple visual interpretation to this. At a given point, draw the tangent. Wherever the tangent intersects the x-axis, that's your next point. Okay, you want to solve it iteratively. Starting at x0, you want to find the next value. You want to, using x1, you want to find the next value. You want to keep on doing that until hopefully, xn equals xn plus 1, or xn and xn plus 1 are sufficiently close together, or thing converges. How do you do that? Actually, there's a f of x equal to 0. Okay. Your next guess, f of x n plus 1. Linear Taylor series expansion. Fit a tangent, that means put a linear Taylor series expansion about old point. F of xn plus xn plus 1 minus xn, that is delta x into f dash of xn. F dash of xn. Derivative of f. Higher order terms we have neglected. This first order approximation, Taylor series. F of x is f of a plus del x minus a into f dash of a. Right, just one term in the Taylor series. What kind of a for the next xn we want to make sure we get closer and closer to f of x. We start with some random guess xn. We start with an x0 randomly. The next value we want it to be better. How can we quantify that in this equation? Next value, at least we are hoping that it satisfies this equation. If it actually satisfies that equation, next value okay, if it satisfies that equation, notice should be equal to 0. If it satisfies the equation exactly, but we want to at least satisfy it approximately in the Taylor series. This is what you are trying to solve. Given a guess, the next value at least make sure that is given xn plus 1th value, make sure that function is 0. Solve for it. Find xn. That's what you are doing in Newton-Raphson. If we do that, rearrange this, notice xn plus 1. Okay, you can have this f of xn to this side, that is minus f of xn. You can bring this derivative to the denominator, that is f dash of xn. Then you can also bring this is xn plus 1 minus xn. You can bring that xn to this side. This is the equation for given xn. How do you find the next point? Current guess xn. How do you find the next value of x? This is the equation. Question is, this is not in f of x equal to 0 form. What is f of x here? At least can you answer that? I'll complete the rest of the problem. Can you answer what is f of x here? If you are trying to solve g of x equals x. See, linear equations, we know how to solve. Any non-linear equation, this is the numerical method to solve it. For example, you can find roots using this in a computer. How do you find roots in a computer? Okay. You look for solutions of this function. X square minus 4 is 0. F of x is x square minus 4. You are looking for solutions of, this equals this. Okay. Yeah, let me leave that here. Okay. Example. Okay. Your f of x here is, you want to set g of x minus x equals 0. So f of x, f of xn. F dash of xn, f dash of x is g dash of x minus 1. Okay. So notice your xn plus 1, that the next point is going to be xn. Okay. F of xn is g of xn minus xn by f dash of xn is g dash of xn minus 1. Can you do this algebra and tell me which of the 4 options is this RHS? What they want is the next point, right? Xn plus 1 is the approximation to alpha at the n plus 1th iteration. They are trying to find the root. N plus 1th iteration is this. Can you at least answer this right now? Simple algebra here. You know, multiply xn by this term, cancel terms, and pick this thing. So this is not going to be g dash of xn plus 1. It's not going to be g of xn. Yeah, it doesn't get to that level of cancellation. It's between this and this. Right. Okay, just answer that one. One out of the 4 options, and then we'll wind up. Yeah, thanks to actually Zoho survey, they are providing this for free, right? They have paid version which will eventually use, but right now they are providing this for free. So I don't mind having uh, their uh, their names in these videos. And also, it's a nice Indian company, right? If possible, I actually want to support them. Given an option between, uh, Microsoft and Zoho, I'd always like to pay for Zoho. So right now, I do like having this here. Okay, and we do, of course, going to get paid versions when the actual need arises. Did anyone complete it? Xn g dash of xn minus xn and plus xn will get cancelled. Minus g of xn by g dash of xn minus 1. It's option B. Okay, so let's okay, we decided to go till 7. Okay, we have discussed the solution. Again, let me point out, every year the question paper shows up, students are full of surprise, and I put up a solution. I also make a big mistake of prematurely putting up the solution to the gate questions online. Most of the students look at the day before the exam and then show up. That I know from my YouTube data. Okay, what happens during the exam is actually they get really surprised. When you discuss a solution, it appears easy for some of these questions. Some of the questions are also very concepts are very expected. As I said, this 2 marks, let me say how much, minimum marks that one could have got. This 2, okay. Limits also, I'll put it out of the thing. Okay. Residue, 3 marks. Okay. Okay, this function unitary, they kinda put a googly there, fine. Residue theorem, 2 marks, 5 marks. Analytical function, verification. Let's say half a 50% of the mark, 6 marks. It's hard to get some of this. Gauss theorem, okay, 8 marks. Probability again comes with practice. Newton-Raphson, 1 mark. So at least 6 plus. Okay, 6 plus, 7 plus is very, very predictable concepts. Okay, 7 plus out of 15. It's predictable concepts. Predictable concepts. Okay. And notice I also was very, very lenient on, okay, forget those 8 marks, but the 7 plus marks will count a lot towards, clearing the cutoff. Very predictable or, predictable or repeating, recurrent. Again and again, they ask the same concept. Okay. At least know that. Okay. And we'll give you sufficient, the point of this is to exam. When you look at the question, it's always this big surprise. Is it even there in the syllabus? Then when someone discusses it, it's, oh, this is actually, I should have done it. I made the silly mistake. I didn't think about it. All these shots are raising. The point of all this diagnostics and all that is to actually minimize this and, get at least 7 plus, if not 10 plus, 13 plus and all that. I'm glad some of you actually in the first attempt got 11. Okay. And some of you improved, gave it again, improved your score even before we discuss the key. That is also good. Okay. But all of you still have time. Okay. And we'll also set, we will set conditions for you to practice, learn, and grow. How you make use of that is up to you. And right now, next Saturday, okay, let's just finish this. There is a GA diagnostic. Again, that's also where we have another issue. We want to find a balance between revision, that is looking at the entire of GA, and focus, that is look at one subject at a time. This is a balance. If I just tell you, okay, next week questions are going to be from spatial aptitude, all of you only read spatial aptitude, you will all forget verbal, analytical, quantitative aptitude. But at the same time, it's from entire GA, then you have too much to kind of cover. So let's do 2 topics. Okay, let's do quant or analytical. Questions, 10 questions will either be from this or from this. Okay, not from both, out of the 2. So revise these 2. Forget about verbal, spatial for the time being. Revise these 2. You'll have questions from only, one of them next week. Okay, in that way, there is a, we are balancing between revision and focus, and try to improve your accuracy and your score. Okay, so this is the end of